right? Let's see if this one is easy for you now. This block is of mass m, and suppose the wedge is of capital M and this angle is theta, and we have this kind of arrangement. And the wedge is not fixed, wedge could move, wedge is lying on a frictionless surface. Now think, what's going to happen? The block would go down the inclination because there is some force, and because the wedge is free to move, it will move towards right. So the wedge will be always in contact with the flow, so it will always move horizontally, it will always have a horizontal acceleration A. And because block is also in contact with the wedge, so the block must also go along with the wedge. So because of that reason, block should also be having acceleration A along with the wedge with respect to ground. Now, with respect to wedge, block is not moving horizontally. With respect to wedge, it is only going down the inclination with an acceleration of B. That's it. And like in the last case, we wrote equation of motion for these two directions. Similarly, for this case, you have to write equation of motion. So try this one. Fight tooth and nail with this problem and find the value of A and B. Okay, the answer would be A and B would come out to be equal in magnitude, and that would be mg sine theta upon capital M plus 2m into 1 minus cos theta. This is what you must have got. You got it? Good, you did it. Now let's discuss the equation of motion in horizontal direction for the whole system. The only external force is tension. Am I right? Just thread tension, and that should be equal to mass into acceleration. Did I write this equation correctly? Mass into acceleration, this block net horizontal acceleration, there will be component of B as well. So this is one of the equation for motion in horizontal direction, and if you look for the inclined plane, if you look for the block as a system, then the net force down the plane will be mg sine theta minus tension. This is the net external force down the plane. That should be equal to mass into its net acceleration along the plane. You'll have a component of A as well, B minus A cos theta. Now there are three variables, A, B and T, and you have only two equations. There's no way on this earth that you can solve all these three. So you have to look for a third equation, and that third equation will come from the constraint relation. This is L1, this is L2. You know that L1 plus L2 is a constant. So if you double differentiate it, d square L1 upon dt square, that should be equal to minus d square L2 upon dt square. And you know that d square L1 upon dt square is the acceleration of this block. So this is B, and this d square L2 upon dt square is negative of the acceleration of A. So this is A. This is a negative of the acceleration of the block along right hand side direction. This negative sign we had a discussion before when we were studying the constraint motion, because this L2 is going to decrease, so dL2 has a negative sign. So this is a negative number, and clubbed with a negative sign, that becomes a positive number, that becomes A. So B is equal to A, that comes from here. And now using these three equations and a little bit of manipulation that you have to do, you'll get A is equal to B, which is this. Should I teach you how to solve the equation? No? Good. Okay, so if we have done successfully first two problems, then you must also succeed in solving the third. Okay, so this is a much simpler case this time. Two blocks, both of mass m, and the system is the system is smooth, whole contacts are smooth. This is a frictionless surface, so everything is going to move, nothing is fixed. This is a simple case. So you find the acceleration of both, net acceleration of both. Okay, so let's write the equation of motion. For this block, pulley, and this block, the only external force is the tension. So T should, and if we are assuming that the whole system is going along horizontal with A, and this is going down with acceleration of B, then along horizontal direction, the only external force is T, right? So this external force should be equal to mass, that is 2m, into acceleration. That's it. Total mass into acceleration. B component of B will not come because it is perpendicular to A, right? And along this vertical line, if you write equation of motion, that is mg minus t, that will be equal to mass into acceleration, m into b. Now you have three variable a, b, and t, so you got to look for third equation that will come from the constraint relation. And from here very easily you can see that A will be equal to B. Okay, can you see that? And you solve it. It's pretty simple. And you will get A is equal to B is equal to G by 3. So what is the acceleration of A and B, of both the blocks? So acceleration of this block, calling it as A and this as B, acceleration of A will be equal to G upon root 3 I cap. This is how you will give the answer. And acceleration of B would be G upon 3 I cap minus G upon 3 J cap, right? Now suppose they are asking how much is the tension. Tension, again you can find out how much is the tension. From these three equations you will get tension is equal to 2mg by 3. Suppose they ask how much is the normal reaction at this contact between the block. The normal reaction between the block will come out to be, and find your answer before looking at it, the normal reaction between the contact would be mg by 3. Not difficult to find? Okay. So it was pretty easy. Fine.